Hi, my name is Jana Crawford. The date is August 9th, 2026, and this is my Unit 2 3-point gene mapping assignment. So what type of problem is this, and what are the steps to solve it? This is a 3-point gene mapping problem that is utilized in genetics. We use this problem in order to figure out where 3 genes are located relative to each other on a chromosome and can calculate the distance between them. The first step we need is to organize the data and put all offspring classes and their numbers into a table, which I provided on the left. Next, we can add everything to get the total number of offsprings. The total number of offsprings in this problem is 5,742. Next, we can find the parental classes by searching for the 2 largest numbers in the dataset. In this example, the 2 largest numbers will be ABC, which is 1,362, and plus, which is 1,340. These 2 numbers are the parental or non-recombinant. After determining the parental class, we can find the double recombinant class by looking for the 2 smallest numbers. So in this example, the 2 smallest will be genotype A++, which equals 100, and genotype plus BC, which equals 140. These 2 are the double recombinant class. Now we need to find the middle gene by comparing a parental class with its corresponding double recombinant class. So for this example, we can use parent ABC and double recombinant A++. When we compare them, we should make a chart to visually see it easier. And I provided that chart on the bottom. And from reviewing the chart, we can see that the genes stay consistent in A. And this means that A is the middle gene, and so the gene order is going to be BAC. Now we can actually calculate the distance between each pair of genes. So the first interval is going to be from B to A. To do this, we will take the offspring that results from a crossover between B and A, and this includes the recombinant class. So we'll add 400 plus 420 plus 100 plus 140, which equals 1,060. Then we can divide that by the sum that we got earlier, which is 5,742, and multiply it by 100 to get the percentage. And this will equal 18.46%. This number means that B has an 18.46 map unit to A. We will do the same method again to figure out the map unit from A to C. So for this part of the problem, it'll be 970 plus 1,110 plus 100 plus 140, which equals 2,220. Then we can divide it by the sum, which was 5,742, and multiply it by 100 to get the percentage. For this one, it'll be 38.66%, which means that there is a 38.66 map unit distance between C and A. For the next step, we will observe the recombinant class by adding the 2 together. 100 plus 140 equals 240. Then we will calculate the expected number using this equation. Expected DCO, which stands for recombinant class, equals B minus A recombination times A minus C recombination times the sum, which will be 0.1846 times 0.3866 times 5,742, and this will give us our observed and expected. So the observed DCO will be 240, and the expected DCO will be 410. Finally, we will calculate a coefficient of coincidence and interference using this formula, COC, which equals observed DCO divided by expected DCO. And this will look like 240 divided by 410, which equals 0.586. This means that our coefficient of coincidence is 0.586. And then for the interference, we will use this formula, and it will look like this, which is 1 minus 0.586, which equals 0.414. Multiply this by 100 to get 41.4%, which is the expected double crossovers that were prevented by interference. And then lastly, this is how the final map of the chromosome would look like. B is 18.46 map units away from A, and A is 38.66 map units away from C, with a total map unit distance of 57.12. Thank you.